ముందుగా ప్రియమైన విద్యార్థులకు మరియు వారి తల్లిదండ్రులకు నమస్కారం. నా పేరు కె వెంకన్న జూనియర్ కాలేజీలో చైర్మన్. నేను ఈ రోజు 10th క్లాస్ విద్యార్థులను దృష్టిలో పెట్టుకొని మాట్లాడడం జరుగుతుంది. అది ఏమిటనగా, మనందరికీ తెలుసు, గత 2 సంవత్సరాలుగా కరోనా కారణంగా విద్యార్థులు ఎటువంటి పరీక్షలు రాయకుండానే పై తరగతులు పంపడం జరుగుతుంది. ఫలితంగా ఐఐటి జేఈ మరియు నీట్ లాంటి జాతీయ స్థాయి పరీక్షలను సాధించడం కష్టతరం అవుతుంది. దీనిని అధిగమించడానికి మరియు 10వ తరగతి పరీక్షలో అత్యధిక మార్కులు సాధించడానికి నేను మీ ముందుకు కె వెంకన్న జూనియర్ కాలేజ్ ప్లాట్ఫామ్ ద్వారా అనుభవజ్ఞులైన అధ్యాపకులచే ఉచిత వీడియో క్లాసులు, హ్యాండ్ రిటన్ నోట్స్ మరియు గత ప్రశ్నపత్రాల సమాధానాల విశ్లేషణ ఇవ్వబడును. కాబట్టి నేను విద్యార్థులకు చెప్పదలుచుకున్నది ఏంటంటే, ఈ ఉచిత వీడియో క్లాసులను మరియు హ్యాండ్ రిటన్ నోట్స్లను క్లాస్ రూమ్లో కూర్చొని చదువుకున్నంత సీరియస్గా చదువుకోవాలను. ఇంకొకటి ఏమిటనగా, ఈ యొక్క క్లాసులు విన్న వెంటనే అర్థం చేసుకొని ప్రాక్టీస్ చేయవలను. ప్రాక్టీస్ చేయడం అంటే కేవలం చదవడం కాదు, పేపర్ మీద రాయవలను. అలాగైతే గుర్తుండిపోతుంది. దీంతో పాటు మీ యొక్క నాలెడ్జ్ని పరీక్షించుకున్న కొరకు త్వరలో ప్రీ ఫైనల్ పరీక్షలు కూడా నిర్వహించబడు. ఈ యొక్క అవకాశాన్ని సద్వినియోగం చేసుకోవాలని 10th చదివే విద్యార్థులకు విజ్ఞప్తి చేస్తున్నాను.
Well, let us do one problem in our Telangana state syllabus, real numbers chapter, exercise 1.1. Use Euclid's algorithm to find HCF. With the help of Euclid's algorithm, we have to find highest common factor of these two numbers. What are the numbers given? Given 900 and 270 to find HCF. Otherwise, without using algorithm method, how to find? I am just doing it on the rough. This is rough, which I write it as you learnt in your previous classes. Take the bigger number inside, 270. How many times 270 will go in 900? If it is 300, 3 times. Approximately 3 times if I say. 3 into 0, 3 into 7, 810. 3 into 270 is 810. 327 is 810 and remainder is 0, it is 90. Now, because the remainder is non-zero, you take this number and divide this 270 with this number. How many times? 3 times. 27, 270. Answer is 0. Therefore, what is the answer? 90. 90 is the HCF of these two numbers. This is what you learnt in your previous year. Here we are doing the same thing with the help of Euclid's algorithm, or you can write it as division algorithm method, expressions, and then work out. So I write 900 is equal to, first start with 270. How many times 270? 3 times. What is the remainder you have? This is 90. What is the original form here? A is equal to BQ plus R form. This is algorithm, division algorithm which you learnt. Now take 270 and take the remainder. How many times it will go? 3 times. What is the remainder? 0. Stop. When the remainder is 0, you can stop it. What is the answer here? Therefore, HCF is equal to 90. This is the answer. You use Euclid's algorithm to find HCF. The HCF of these two numbers is 90. Highest common factor. For verification, I am writing it here. Verification. What is 900 written as? 90 into 10. What is 270 written as? 90 into 3. You can see here 90 is the common factor. Therefore, the answer is 90. Understood? So, you should stop this when R is 0. Remainder is 0. The Euclid's algorithm method is stopped. Find the HCF. Found the HCF like this. This is the way you have to do it.
Students, my name is Vishal Sharma and I did my BTech from IIT Kanpur in Electrical Engineering. I have an experience of more than 12 years in preparing IIT JEE aspirants for this examination. Under me already more than 100 students have cracked this IIT JEE examination. Right now I am associated with K. Venkana classes. Now K. Venkana classes, for the first time in Hyderabad, it has brought your top Delhi, IIT and NITN faculties. Now what are you waiting for? Come and join us and realize your dream of getting into IITs.
So we are going to do one more problem in the exercise 1.2, Telangana State. Express as product of 5 factors. Earlier when I was telling you the fundamental theorem of arithmetic, I explained this, how to split that into prime factors. We are given 3 examples. First example is you are given 140. How to find it as the product of prime factors? Always start with the minimum. 1 is always possible, don't start with 1 because 1 is always a factor. If you want to write it, 1 into 140 you have to write, you don't need to write it. Start the first prime, 2. Will 2 go here? Yes. How many times? 70. Next 2 into, again 2 goes because it is an even number. In 72, how many times? 35 times. Next 2 into, 3 will not go, 4 will not go. You need not check up with 4 because if at all it goes with 4, already 2 tested. So 5 into 7. Therefore, express as product of 5 factors. How many primes are there? 2 is a prime, again 2 is a prime, 5 is a prime, 7 is a prime. This is the answer for the problem. Next take 156 and express this as the product of prime factors. Start with 2. 2 how many times? 7 times, 16, 8, 78. Next again you can test it. 2 into, again test with 2. 3 times, 18, 19, 9 times. So 2 into 39. 4 times, sorry, this is 2 goes, I am repeating it, 2 goes here 3 times, 3 into 2, 6, 18, 18, 2 goes 9 times. So 2 into 39 is the answer for 156. Again 2 into 3 will go here 1 time, 3 times, 13 times. So what are the factors? 13 cannot be split. 3 is already a prime number, 2 is a prime number. Therefore, this is the answer. You can write this in short, 2 square into 3 power 1 into 13 power 1. This way also you can write. This answer is correct. This answer is also correct in the examination. Understand? This you can express it as 2 square into 5 power 1 into 7 power 1 means 2 how many times? 2 times. 5 how many times? 1 time. 7 how many times? 1 time. Coming to the third bit, 3825. How do we split this? Will 2 go here? Because this is a number which is ending with 5. 2 will not go. It is not an even number. 2 will not go. We can test for 5 directly. 5 into, in 38 how many times? 7 times. Or else you can go by this method, 3825 divided by 5. How many times? 7 times, 35. 3 is the remainder, 32. 6 into 5 is 30. Remainder is 2, 25. 5 times. So it is 25. Answer is 765. You can write it this way. 5 into, again 5. Shall we try for that? 765. How many times 5 will go? 1 time. 2, 6. 5 times, 25, 1, 5, 3 times, 15, answer is 0. So you can write this again, 5 into 153. Now, can we try by 3? 153 divided by 3, 5 times, 15, 0 is the remainder, 3 comes down, 1, 3. So 3 into 51. 5 into 3 into 51. Now you have to try for 51. How many times? 5 into 5 into 3 into, is it 3 into 17? 3 17s, 51. Next, 17, can we split 17 into further factors? No, 2 will not go, 3 will not go, 4 will not go, 5 will not go, it is a prime itself. So arrange in ascending order. How many 3s are there? 2. How many 5s are there? 2. How many 17s are there? 1. So this is the answer. All this is rough. Take down this problem, and I explained 3 problems once again. Take any number, start division, test with 2, then 3, then 4 and so on. Write maximum number of possible prime factors as far as you can. If further factorization is not possible, stop. You stopped here. 156. 2 twice will come, 3 will come once, 13 will come once. So like that prime factors have come. So this is product of prime factors. I have written it. The next example is 3825. It's a little bit tough. So if you want, you can use it as rough. Always in the examination, write the rough work on the right side. However it may be, you can write it. This way you can find the prime factorization.